Hello everyone, this is Sharia. So in this video we are cover our second header file called Bitset. Okay, so this is our left side. Our title called Bitset Comprehensive C++ Programming Guide also has a description. Okay, then you can see our license called GPL license. Okay, this is not a LPGL. This is a GPL license and also a MIT license. Okay. So you can see the author and GitHub and institution, version, date and credit, and also license. You can see it. Okay. So let's get started our today's session called Mastering C++ in Comprehensive Guide with header called Bitset. Okay. So in the left side you can see our description of Bitset. Okay. What is the description? Okay, what is the Bitset description? The Bitset header is a C++ provider, a powerful to handle fixed size binary data. That you can understand that here we can perform our data called fixed size. Okay, fixed size bit or binary operation. Okay, efficiently. Okay, unlike the vector bool. Okay, which is dynamically allocated, and Bitset or a steady Bitset uh, vector n also or bit is memory efficient, uh, fast and ideal for Bitset operation. Okay, the key features or features. Okay, fixed size sequence of Bitset, fast efficient implementation, fast bit size operation, and compile time size determination, and direct bit manipulation capabilities. Okay, this is our the key features of our Bitset. Okay, Bitset header that we have a fixed size sequence of n bit and memory efficient, fast bit operation, bitwise operation, and compile time size declaration. Also we can compile time declare our size and direct bit manipulation capabilities. Okay, then next our common use case. Okay, bug management and binary operation and state tracking, memory efficient boolean arrays and bit manipulation task. Okay, this is most important of our key set. Okay, bit set features. Okay, this is most important. Okay, these are features, these are description, and this is our example. You can see 1 2 3 4 5 6 7 8 9 10 function, call set function, reset function, flip function, and count function, NA function, and non function, and size function, test function, two unsigned long function, two string function. Okay, and this is our implementation, that if we call this function called set, then we can set all the bit 1. If we call the function called reset, we reset all the or we set all the we set all the bit to 0. Okay, if we call the function called flip, that we toggle to the bit, like if the original bit is 1, we toggle it 0, and if the original bit is 0, we can toggle it to the 1. Okay, then we count how many bit are there. Okay, then we count, and that we any there check if any bit of the 1, when we call the function any, and non 0, when we check all of the bit to the 0. Okay, no, and the size function, we just return the total bit of the size, and the test I, that means if we check the bit in index is I. Okay, we also cover in this later, and we also covered this two and this all of the later in the tutorial. Okay, example. Okay, then these our pro tips for learning, Bitset faster. Okay, these are our 5 tips. Okay, tip number 1, visualize binary representation. Okay, use standard or std bitset to string for clear binary visualization. Practice reading and interpreting binary pattern, and experiment with different size of the bit set. Okay, this is our visualization binary representation. Okay, and the tip number 2 is the write small experiment. Okay, that set, reset, flip, count, and solve bitwise operation means parity checking. We also check it. Okay, our carry checking also, parity checking, gray code checking, humming code implementation, and subnet mask calculation we also cover in this later. Okay, performance comparison. Okay, performance comparison with vector bool, like memory efficiency, access speed, and operation performance. Okay. Then real world application is that study to practically use it, like cryptographic algorithm, data compression, and network programming, and also error correction, and also Bloom filtering implementation. Okay, so let's go. Our first implementation of Bitset is called example 1 to Bitset operation or basic Bitset operation. Okay, so we just uncomment our code. Okay, we just uncomment our code, and here is our left side called our draw pad. Okay, so first here you can see the our code that it said our we just declare our bit set call 8-bit and also declaration with the bit that this is our 8-bit binary bit, and we also operation this 8-bit in this later. Okay, so first we create our bit. Okay, this is our 8-bit. Okay, this is our okay one. I also provide in the document which I perform in the link in the comment below. Okay, 1 2 3 4 5 6 7 8, but in the code section we also call it like 0 1 2 3 4 5 6 7. Okay, so here is our 8 bit. Okay, this is our 8-bit memory. Okay, this is our 8-bit memory. Okay, and in this 8-bit we also perform our code. Okay, so in this 8-bit memory this is called a bit. Okay, this is called a bits. Okay, this is called a bits, and we are indexing as like 0 1 2 3. Okay, 3 0 1 2 3 4 5 6 7. Okay, so if we put our initial value of that like if we put our initial value of that 0 1 0, here is our initial value. Okay, 0 1 0 1 0 1 0 1. Okay, this is our initial value. Okay, then we just count it, then we just paint it. Okay, then we just see out it the initial value, and this is our first this is our first operation. Okay, this is our first operation. Okay, this is our first operation. Then we just perform our first function called set function to the 0 position. Okay, this is in this 0 is the 0 position, like this position. Okay, then what is that, we just set it to 0 position. So first create our memory to the 8-bit. Okay, then 1 2 3 4 5 6 7 8. Okay, now we just change, or we just set in the 0 position. In the 0 position, like that, our first position, the bit is 0. So in this case, if we set that, we just set it to the 1. Okay, why 1? Then in the here you can see, if we call our set function, we set all the bit to the 0. Here all means only for this 0, this 0. So rest our code is like 0, and rest of it 1 0 1 0 1 0 and 1. Okay, so this is our two operation called, this is our set operation. Okay, this is our set operation. Okay, now go to our rest operation. Okay, now go to our rest operation. Now you can see first this is our initial value, and those set operation, then this is our initial value. Okay, this is our initial value, and we perform in this to our reset operation to the position 1. Okay, the position 1 to reset operation, there what is the reset operation? The reset operation is there, set all the bit to the 0. Here we all bit means in the 1 number position. Okay, so first we just create our memory or our bit set or our memory to the 8 bit. Okay, 1 2 3 4 5 6 7 8. Okay, so this is our reset. Okay, reset operation. Okay, this is our reset operation. So here you can see our 1 number position. Okay, 1 number position has only 1 number position has a reset. So you can see our 1 number position is bit is 1, so we just put it to the 0. Then our rest of the code are as same as it is, like a 1 0 1 0 1 0 1. Okay, now we got our 3 operation. Okay, initial value, set and reset. Okay, now we flipping. Okay, now we flipping our bit. Okay, so you can see we just create another memory. Okay, or bit set, you can just say that if you wish. So it's just set our another bit sets. Okay, 1 2 3 4 5 6 7 8. Okay, this is our another bit set. Okay, thus we just flip it. Okay, so here you can see if we just take a flip. Okay, flip. Okay, if we set is a flip. Okay, so now this is our initial value in this case in flip operation or flip function. So you can see we know that when we call a flip, then we toggle all the bit. Okay, now we just want to toggle it to the 0 and 2 1 0 0 to the toggle it 1 1 and 1 equal to 0 and 0 equal to 1 1 equal to 0 0 equal to 1 and 1 equal to 0. Okay, this is our flip operation. Okay, or flip function. Now you gotta see our another out number of the set bit. Okay, number of the set bit in count. Okay, so in this case we see that our set bit like 1 2 3 4, our set bit is a 4. Okay, our set bit is a 4, and also in the bit position of the test, two number bit position 0 1 to 2 number bit position. What is that? So 2 number bit position is the 1. Okay, 2 number bit position is the 1. Okay, so if we run that. Okay, if we run it. Okay, if we run this, so how we can run it? First we go to our terminal and write g++ minus std equal c++ 11 Also our type our code like bitset dot cpp and minus o bitset. Okay, then if we run it, okay, if we run it, where you can see where is the code. Okay, we just miss another one. Okay, okay, if we run it, and go our bitset. Okay, so here you can see our initial value, our after 0 bit. Okay, uh, our set operation. Okay, this is our set operation, our reset operation. This is our, okay, this is our reset operation. This is our flipping operation, and this is our number of bits, and this is our bit position. Okay, okay, okay. I also put the note here. You can see I also put the note in the link of the description. Okay, also in Udemy or on my course. Okay, okay. Now we go our second modifying Bitset. Okay, this is also common modification. This is also a common modification also. Okay, let's perform it. That what is our final value of b? Okay, we just modification it. Okay, so first, so here first we just create a three of the our bitset memory. Okay, three of the bitset memory first. We also headline it to the example. Okay, example 2. Okay, example 2. Okay, so here is our first bitset memory, this is our second bitset memory, and this is our third bitset memory. Okay, so this is our three different bitset memory. Okay, is the first 1 2 or 0 1 2 3 4 5 6 7 8. Okay, sorry, just mix up 0 1 2 3 4 5 6 7. Okay, now 0 1 2 3 4 5 and 6 7. Okay, now another is 0 1 2 3 4 4 5 6 7. Okay, now the final output is the our b. Okay, and we also have a modification bits of 3 operation. Okay, and okay, so this is and this, and this is our final b. Here we get our final b, and this is called a set, oh sorry, set to reset, set to reset, and this is called reset to flip. Okay, flip, reset to flip. Okay, So here you can see our first value. Okay, our first value. Okay, our first value is that 0 1 0 1 0. No, we just messed up. That first our first position is set. Okay, so now we just here our 1 then 1. Okay, 0 1 0 1 0 and 1. Okay, this is our set operation. Then we go to the next operation, to the set to reset operation. Okay, so set to the reset operation. So here is the reset operation to our reset one number position. Okay, 0 1 and one number position is to the 0. Okay, and our rest of that to 1 0 sorry 0 1 0 1 0 1, and next is that to flip 2. Okay, flip. Here you can see when we call when you just call flip, then we flip all of the bit. When we just call in 2 like that, when we just call flip 2 like 0 1 2, only 2 number position we just flip it. Okay, okay, we can see 0 1 2 number position is 0, then we can flip it to the 1, and our rest of the operation is that 1 0. Okay, 1 0 1 0 1. So here is our final output to the 1 0 1 0 1 1 0 1. Okay, okay, if we run that, we can understand how we can find it. Okay, so just go our terminal. We just go our terminal, run it and see it. Okay, this is our final code. Okay, this is our final code. Okay, so we just create another. Okay, so now this is another most important, our bit operation to the AND or an XOR operation. Okay, and this is our most important. Okay, so I just here 10:27 AM. Okay, so first here you can see our 2 bit set in the 4 bit. Okay, so first this is 1. Okay, this is 1 and this is 2. This is called B1 and this is called our B2. Okay, so 0. Okay, 0 1 2 3. Okay, zero, 1 2 3. Okay, our first bit we counting like, okay, our first bit equal to 0 B1 0 1 and 1. Okay, this is 0 0 1 1, and another second is 0 1 0 1. Okay, now we perform our AND operation, OR operation, and XOR operation. Okay, so how we can, so this thing, so we need a 3 of the table. Okay, so first create our table called, okay, 3 table. Okay, so this is our first table. This is our second table with the OR operation, and this is our third table. Okay, the XOR operation. So first we can create our heading, and then we 0 1 2 3, and this is our B1. Okay, this is our B2, and this is the AND operation. Okay, and here you can see 0 1 2 0 1 2 and 3, and this is our B1, this is our B2, and this is our OR operation, and this is our third. Okay, 0 1 2 3, this is our B1, and this is our B2, and rest of our XOR operation. Okay, so let's get started our B1. Okay, first we can heading it to the B1, B2, sorry, B2, and this is called our first AND operation. Okay, we can denote it to the A. Okay, AND operation we can denote it to the A, and this is a called B1. Okay, B B2, and this is our OR operation, and we can denote it to the O, and another is B1 B2, and our XOR operation, and we can denote it to the X. Okay, this is a simple calculation. So our B1 to 0 0 1 1. Okay, 0 sorry 0 0 1 1. Okay, another is 0 1 0 1. Okay, 0 1 0 1. Okay, if we end our operation, if we operate our AND operation, so we know that in AND operation is like a multiplication of 2 bit. Okay, so if we multiplication our 2 bit, like 0 0 is the call 0, 1 0 is the call 0, 1 0 is the call 0, and 1 1 is the 1. Okay, so this is our AND operation, and we can perform it to the 0 0 0 and 1. This is our final result or final output. Okay, and then we can perform our next operation called OR gate. Okay, here you can see OR 0 0 1 and 1, and also 0 1 0 1. Okay, how you can see. So in the OR operation, we just assume it is like a addition. Okay, binary addition. Okay, 0 and 0 is the 0, 0 and 1 is the 1, and 0 1 is the 1, and 1 also 1 is 1. Okay, so our final output is 0 1 1 and 1. Okay, this is our final output. Okay, now go to our third operation called XOR operation to the 0 0 1 and 1. This is a 1. Okay, and 1, then 0 0 1 0 1. So in this case, in the XOR operation, we just know that is the same bit are occurred like same bit 0 0 or 1 1, same bit 0 0 or 1 1 1 1 or 0 0, then we can just put in the 0. Okay, then we put in the 0, and same case we put in the 0, and a different case we just set is 0 1. Okay, then our final output is 0 1 1 0. So this is our final XOR. Okay, so here you can see our output is states. Now we can just look at up that our answer is correct or not. Okay, okay, here you can see our answer. Okay, this is our answer. Okay, okay, now we counting bit to the checking specific bit. Okay, now here you can see we just count it like c dot count. Okay, so in this count operation we just see that in the count operation we just return to the number of 1 s of 1 count. So how many 1 in our counter like that? 1 2 3 and 4. So in the count b dot count, so our answer will be the 4, and is set 3, and is set 3 or b test is the 1 or not, and 0 1 2 3. Okay, the set of the our test equal to 0. Okay, you can see the test equal to 0. Okay, in the test you can see that in the test section check if the bit of the index is I or match to our or set 1. Okay, so you can see our 0 1 2 3 position of the set is 0, so the answer is 0. Okay, okay, now converting std bit set to the other format. Okay, this is most important, we also understand. Okay, I just forget to tell you guys that one thing like that, just indexing. Okay, just indexing. Okay, this is our experiment ex experiment. Now experiment 5. Okay, I just forget to tell you guys one thing, that our indexing left to right and right to left. Okay, this is most important to confuse you guys to where you can start our indexing. Okay, okay, just here assume that this is a 8 bit. Okay, this is a 8 bit bit set. Okay, 8 bit set memory. Okay, 8 bit set memory, and this is our 8 bit set memory. Okay, so when we just operation like set, reset, rotate, flip, in this case we considering right to left in our bit counting, like 0 1, okay, 0 1 2 3, oh sorry, oh, 2 3 4, like that, okay. But when we operation any string operation, okay, when we operation any string like that, to string or any string operation, okay, then time we count our index to the right side to left side, like this is called less significant bit and this is our most significant bit, okay. Okay, this is our least significant bit and this is our most significant bit. So we can understand it when we set any set operation, rotate operation, flip operation and other test operation, we just counted it to the our, we just we just what is called like priority, okay, we just call priority of our case in the low significant bit, okay, but less significant bit to the 0 1 2 3 4 5 6 7 etc, okay. When we just manipulate our string to bit set, that time we consider our priority to the most significant bit and then we just left to right and cover 0 1 2 3 4, okay, like that, okay. So in this case here you can see our bit set is 0, okay. So in this case just create our bit set called 0 1 2 3 4 5 6 7, okay. Then we can write it 1 0 1 1 0 1 1 0 and this is our indexing for 0 1 2 3 4 5 6 7, okay. 0 1 2 3 4 5 6 7, okay. Okay, so this is our operation. Then our first is that to binary to the unsigned long. So how many long is that? So if we just go to the calculator and we just set it like uh, 1 2 4 8 16 32 64 and 128, okay, like that, okay. We just go to the okay, uh, 1 2 3 4 5 6 7 1 2 3 4 5 6 7, okay, 8, okay. Then we set it like a 1 2 4 8 16 32 64 and 128, okay. This is our separation. So here you can see our bit, okay. Our bit is called 1 number position is 0, 2 number position is 1 and 4 number position is 1 and this is called 0 and this position is 1 and this position is 1 and this position is 0 and this position is 1, okay. So if we addition it like 128 and we find the 1 is 32, okay, 32. Then our 16, okay, 16. Then our 4, then 2, 2. So if we go our calculator and write it 1, okay, in our Mac we have a calculator called cal calculator, okay. If we just go it and write it 1 2 8 plus 32 plus sorry oh 1 2 8 plus 32 equal 1 6 plus, where is that, okay, 1 2 8 plus 32 plus 16 plus 4 plus, okay, 4 plus and 2 plus. Here you can see our uh, 2 unlock unsigned log, okay. This is our unsigned log number is 182, okay. This is our final output to the 182, okay. This is our 182, you can see this is our 182 and this is our 182 and this is our first operation has done, okay. And our second operation is the binary to string, okay. Binary to string like that, binary to string is that to a string, like this is our called string, okay. So the who is our string, like that 1 0 1 1 0 1 1 1 1 0, this is our string, okay. So if we run it, okay, our terminal, okay, if we run it to our terminal, go to our Bitset and our terminal, then you can see our code, okay, like that, okay. So this session we will divide it in the two parts. So our first part is covered and in the second part I will cover in our 15 example also our some of the code, okay. That's till then, thank you so much and have a great day. Hello everyone, this is Sharia. This is our second tutorial of Bitset comprehensive of C++ all our header. So this is our example 6. In the 5 of the example we are covered in the first part. So this is our second part. So let's get started our video. So this is our second sixth example. So in this example we are comparing two two bitset instance, okay. So this is our first instance, second instance, third instance. We just compare these two b1 and b2 are equal. So this is, we can see these are equal, and b1 or b3 is not equal. This is, you can see this is not equal. So that's why this is called me the answer of but 2. So if we run that, okay, if we run that and see, then this will be the our one, that means true, okay. Okay, so now this is our 7th example, okay. Okay, this is a simple for loop, just to print this to one by one to the index size. So you can see the custom print that size t, that is the size of the I, and we can compare it to our bit size like b, and is the size that 8, okay. Then we can here increase it and we can see out it, okay. we'll see out is I also the BI index. Okay, so if we run that, if we run it, okay, if we run it and see it, okay, so this is our output. Okay, so this is our one of the most important topic to the example 8 to the binary addition. So our most of the case we are compare this or finding this how to solve the binary addition to this program. Okay, so here you can see our two bit set. Okay, b1 and b2 also we can perform a binary addition in this criteria, also our while loop, so we can perform it also. Here you can see our right side is the whiteboard, then we can write it. Also you can see our note, also the first part, also second part, sorry, first part note we also uh, put in the course title that you can find it. Okay, so first in this lecture or in this particular example we are only cover only 4 bit. Okay, because rest of the 4 in 8 bit, rest of the 4 is in this case are 0, so we just compare it to the word. Okay, so first we create a two box or two address. Okay, two address, sorry. Okay, so this is our b1, this is our b2, also this is a example called 8. Okay, this is a example, this is example 8. Okay, now we have a index 0 1 2 and 3. Okay, this is our 4 bit. Okay, 0 1 2 and 3. Okay, in the first b1 we have a, sorry, we have a 1 0 1 1 and our b2. Okay, it is 1 1 0 and 1. Okay, this is our 2 bit. Okay, so just we simplify our code, we just shortly determine our XOR, also this carry, result or carry. Okay, so our first to determine result. Okay, so in the simplify that we just write our first alphabet called R to find our result in the XOR. Okay, so we know that in the XOR position the same bit will be the 0 and different bit will be the 1. Okay, so our first bit and first bit will be the same, that we can cover it to our 0, sorry, then we just call it to the 0. Okay, 0, and our second bit and second bit are different, then we can cover it 1, and our third bit and third bit will be the different, we can cover it 1, and our 4 bit and 4 bit are the same, then we can cover it to 0. Okay, now the carry time. Okay, now this is our carry. Okay, in the carry, so you can see in the OR position 1 will be the 1 will be the 1. Okay, 1 1 1 will be the 1, and 1 or 0 will be the 0, and 0 or 1 will be the 0, and 1 and 1 will be the 1. Also we can perform it with the left shift. Okay, left shift to the 1 position. Okay, so in the left shift to the clarify it. Okay, that we got sum. In this case, this will be our carry, then we can sum it to the 0, 0, 1 and 0. Okay, sorry, I have a mistake. Okay, let's define it. This is not a 0, that. Okay, 1, 2, 3, 4, also 5 will be the 0. So in the left sheet we can define 1, 0, 0, 1, 0. Okay, this is our left sheet condition. Okay, so if here will be the same the right sheet, then the 0 will be the left side. When it say the left sheet, then will be the 0 will be the right side. Okay, this is most important. Okay, now to perform our this particular example, we have to cover a 3 step. Okay, 3 step. So okay, 3 step, we need a 3 step. Okay, our step number 1. Okay, step 1. Okay, so in this step 1 we have our temp, also our result in 0, 1, 1, 0. Okay, and our carry will be the 1, 0, 0, 1 and 0. Okay, now our first condition to result equal to result XOR carry. This is our condition. Okay, this is one condition, so let's perform it. Okay, so let's perform it to our result. Okay, result equal to our first condition is to 0, 1, 1, 0. Okay, 0, 1, 1, 0 XOR 1, 0, 0, 1, 0. So let's define our answer. Okay, same bit 0, same bit 0. Okay, different bit 1. Okay, same bit 0 and different bit, we can assume it as a 0, so different bit will be the 1. Okay, now we can perform our carry operation. Okay, see, carry operation. Okay, carry operation. Okay, now here you can see our temp will be the 0, 1, 1, 0. Okay, our carry will be the this. Okay, this is our carry. Okay, 1, 0, 0, 1, 0. And left shift 1. Okay, so let's define it. Okay, here let's define it. Okay, so AND operation, 0 and 0 will be the 0. Okay, and 1 and 1 will be the 1. 0, 1 will be the 0. 0, 0 will be the 0. 1 and 0 will be the 0. And if we left shift to the 1, then we can find it to the 0, 0 1 0, also a 0. Okay, this is our final output. So this is our final and this is our final. This is our final result and this is our final carry. Okay, now step 2. Okay, step 2. Step 2. Okay, now step 2. So our temp and result, are 1 0, sorry, 1 0 1 0 0, and our are carrier 0 0 1 0 and 0. So let's perform our second step to the R. Okay, result. We are in loop 2 position. Okay, our result are to the 1 0 1 0 0, and this XOR operation 0 0 1 0 0. Now we can perform our XOR. Same will be the 0. Okay, and same will be the 0. Also same will be the 0. Same will be the 0 and same will be the 0, and our different will be the 1. Okay, this is our step 2 R result. Okay, then our carry. Okay, carry. First we need a temp or result 1 0 1 0 0. Okay, then our second hand position is our carry. Okay, 0 0 1 0 0, also in a left shift 1. Okay, then what will be the find? We can find it. Then you can see same will be the 0, and 0 0 will be the 0, 1 1 1 1. Okay, 1 1 will be the 1, 0 0 will be the 0, and 0 1 will be the 0. Okay, then we just left shift. Okay, left shift 1. Then what we can find? We can find 0 1 0 0 and 0. So this is our final carry. Now our final step. Now our final step to the step 3. Okay, now our final step to the step 3. Okay, step 3. Okay, step 3, temp and result. Okay, temp and result is 1 0 0 0 1 0 0 0 and 0, and our carry. Okay, carry will be the 0 1 0 0 0 and 0. Okay, now we are performing our last and final. Okay, last and final result. Okay, last and final result. What will be the result? That we can XOR it. Okay, we can XOR it 1 0 0 0 0, and XOR it 0 1 0 0 and 0. So if we XOR it, then what we will find, 0 0 means 0, okay, and this 0 0 means 0, and this 0 0 means 0, and 1 0 means 1, okay, 1, and 0 1 means 1, okay. This is our final this is our final output, okay. And our final carry will be the 0 0 0 and 0, if you can determine it, okay. Here is our final output is the carry equal to 0, okay. Our program will be the stop stop or false, okay. False here, okay. So this is our final output, and the final output will be the look like this: 1 1 0 0 0 0 0 and 0, okay. This is our final output, okay. If we run that, okay, if we run it, okay, if we run it, and then we can set it, then you can find our final output result and this result, okay. Okay, fine. Okay, now we have another template, okay. I can just remove it, okay. Now our another topic is the palindromic bits, okay. What is the palindromic bit? It's like a mirror, okay. It's like a mirror, we also define it, okay. It's like a mirror, okay. So here we just check it that this and this are palindromic, this and this are palindromic or not, okay. So in this subconscious mind we can say that this is palindromic and this is not palindromic. So how we can define it, this is palindromic or this is not palindromic? Let's see our here to our droplet that we can define it how we can palindromic or not. So first we can header that this is our example 9, okay. This is our example 9, okay. This is our example 9, okay. So to do that we need a call. So to do that we need a 8-bit Bitset, okay. First we need a 8-bit Bitset, okay. 0 1 2 3 4 5 6 and 7, okay. So our bit will be the start with this to this, okay, left side to right side, not the here. In the first tutorial we can define it why the bit start or index will start left or right, or less significant bit to most significant bit, most significant to less significant bit, why this. So in this case we are start to left to right, okay. So in this case palindromic case, okay. So this is our 0 1 2 sorry 2 3 4 5 6 and 7, okay. Now our first position 1 0 0 0 0 0 0 and 1, Okay, this is our first bit set or B1. Okay, B1. Okay, this is our B1. So you can see our first we contain our bit set to the n. And what is the n size? Will be the 8. So n size will be the, here n will be the 8 bit. Okay, then we need a n by 2 because we mirror this, because we that mirror this, that's why we need a sub 2. Okay, then we can just mirror this, we can just mirror it. Okay, then here why this logic? Okay, sometimes you may ask that I not understand or I may not understand how this logic will be performed. So just think of that how we can perform it. Okay, you can see the n when this position, when bit I, bit I is the 0. Okay, bit I is the 0, when bit I is the 0, and another is the this position, right to left and right to left. Then our next is n minus I. Okay, sorry, our n minus I minus 1. So how you can define it? Like a 8 minus 0 minus 1. So how you can define it? That it is 0. Then it check that 0 position and the 7 position is okay. So you can see that, we can see that 0 position and 7 position are absolutely same. Then you can perform our palindromic. So rest our 2, 3 and 4, 5, 6. How we can see that? If our I equal to 1, then our this case 8 minus 1 minus 1, then we can find our 6. So if we can see that our 6 number position and 1 number position also the same, so 1 and 6 also the same. So you can see that it is perform our same. Okay, then our third number position. Okay, our second number position, sorry, third number index, then 8 minus 2 minus 1 is to 5. Okay, then you can see that 2 also the same of 5. Okay, then rest of that, then all will be the defined. So we can say that this is palindromic. Okay, palindromic. But in this case you can see that this 1 and 1 will be the same, that in the our B2 first I 0 and equal to 0 equal to 7, then it perform a palindromic. But in this another case, our 7 second bit, okay, that I2, that not perform a palindromic. Okay, that not perform a palindromic. Also I3 this and this perform a palindromic. Okay, but the 4 and 4 are not a palindromic. So we can here consider it that B2 is not a palindromic. Okay, that's it. So if we see that, and if we run that, okay, if we run that, then you can see, one is palindromic and another is 0 or not palindromic. Okay, that's it. This is our another. Okay, okay. This is another called representation permission using Bitset. Okay, this is as like our first tutorial that we can define it test or test. This is easy that how you can test it, that user dot upper test one, that one is key, one is 0, so this is a false. That if the test is 1, then we can say that it is 1, sorry, it is true. But in this case the test is 0 because the 0 of the index is the 0, but in this case will be the test will be the 1. Okay, then in this case our group dot permit in the test 0 will be the 0, then we can say that the test will be the 0. Okay, here you can see 0. Okay, okay, now we are go to the masking. Okay, this is another concept of programming language or low level language, that masking. So let's understand what is the masking. Here in the right side I just only show you the masking, how we can perform the masking. Okay, okay, so see our it's also 29. Okay, so example 11. Okay, example 11, that masking. Okay, masking. Okay, masking. Here we can perform three type of masking called uh, AND operation. Okay, and masking. Okay, or masking, and X or masking. Okay, to simplify that, in the first section, okay, in the first section we just know that in the AND operation 0 will be the same. Okay, 0 will be the same and 0 will be the same as like it is, and rest will non-masking. Okay, rest will non masking, non-masking, I say again, non-masking will same. Rest non-masking will same. Okay, so in the OR operation 1 will be the same, 1 will be the same, and rest bit. Okay, rest bit non masking are same. Okay, now in the XOR condition, okay, XOR condition, 1 will same 1 1 or fourth one will be the same, and rest rest bit, okay, sorry rest bit will will toggle, okay, T O Z Z L A. Rest bit will be the toggle. This is, so rest bit will be the toggle. So this is our main core concept, okay. So in these three core concept, we can perform any of the X, AND, or an XOR operation in masking, okay. Okay, here you can see our AND operation. So in this AND operation, 0 0 0 will be the same. So 0 0 will be the same, and rest non-masking. This is masking. This is non-masking. Rest non-masking will be the same. So we can find it. Our original bit is this, and the non-masking is 0 0 0 0 0 0 0 0. So we can run it. Okay, here we can run it and see it. This is our output. Okay. Okay. So this 8, this 12, this is another rotation. So this is your home task. You can perform it and just message me or comment me that you can find the exact answer like that, okay. This is your home task to the rotate operation. This is as likely same to the first few of this. We can determine this is a left shift and right shift, and you can call me if you cannot understand. I will definitely make a different video to that, okay. Okay, so finding our first set and answer, we this is the same as it is, okay. So let's define it. So find our first one, okay. So in the first, we can say that if the string operation, that will be the our most significant bit will be the priority first, okay. Okay, if the set reset, then will be the less significant will be the priority first. So here just create a call example, okay, example 13, okay, example 13. Then we create a memory, sorry, we create a memory, and you can define it 1 2 3 4 5 6 7 0 1 2 3 4 5 6 7. Okay, so in the string operation, in string bit manipulation, the index will be the start 1 to here and will be the 7, okay, or 1 to 8, okay. Sorry, 0 to 7 start here, and this will be the 8 bit, okay. So our bit will as 1 0 1 0 1 0 0 and 0, okay. Now to find one, let's set to our set 1. We can see our first set of the bit of the index, first set. Okay, so first set in 1, that here 0 and 1 will be the 0. Okay, you can see the 0 and find the 0. In the 0 will be the 1. Okay, then will be the 1, and you can see the first unset bit. Okay, the unset bit of the index. So unset bit of the index will be the 0. So 0 will be the here, also here. Unset will be the here and here. Okay, unset bit. So we can get 1, 2, 3. So our unset bit index will be the 3, and I am it here very much little configuration, concept, misconcept that we can find 1, that we can find 1 number position is the 0 and the 0. Okay, then we can find a 1, 0, find 0. Okay, this is our 0, and the 0 position, what you can see, unset. Okay, 0 position, we can see the 0 position will be the 1. So if we run it, okay, if we run it and see it, okay, this is a 1. This is a very confusion, that I can assume that this is a 1, not 3. You can see, you guys, sorry, you can see here our 0 number index is 1. Okay, index will be the 1. Okay, 0 index will be the 1. So just to know other, we can just comment it. Okay, okay, I comment it later. Okay, so this is okay. Okay, now this is bitwise our 14 example bitwise operation on multiple. Okay, this is your home task that you can perform it. This is an easy home task that you can perform it. If you follow our 2 video, then you can perform it to the OR and XOR and AND operation. Okay, okay, then our last and final, this is a simple Bitset set data structure. Okay, this is a object oriented or OOP example. Okay, okay, let's see. So you can see we have a class called Bitset, then we have a public property, then we have a public property. We also inherit our bit size. Okay, we also inherit our bit size. Okay, okay, then we create a add function, we create a remove function, we had a create a container function, and in the add function we create our return type and our return type and our return type. Okay, this is our return type. Okay, then we have a public private property, this like, and this will be the inherit this. Okay, size is 32 bit and this size is 32 bit. Okay, then we just cover bitset, and okay, then we just call our class here. Okay, then we just call our class that bitset, then we create a object called set, and this will be the 32. Okay, then is 32, we add a 5, we add a 10, we add a 15, then we set out our everything. Also we can perform our set remove here. Okay, this is our output. Okay, Okay, if we run that, this is very simple. You can perform it. Okay, this is our answer. Okay. Okay, then this is another our some of the Bitset project. uh, you can perform it, our Bitset project. The subnet mask validation, this is a subnet mask validation. Okay, this is a subnet mask validation. So here you can see we create a function. This is our function body, this is our function body, and in this function we create our string reference called binary subnet. Then we can create our subnet, then we can set it our false, then we can logic it. It will be the start will initial value 7, then we can gradually decrease it. It will be the same as like, it will be the same as like this. Okay, it will be the same like this, our example 9. Okay, then we just perform it. Okay, this is so this is another project called custom binary encryption. Okay, this is another project called custom binary encryption. So this is our function, user defined function, and we create a encryption data, and we also create our bit set, also a string called empty. Okay, sorry, it called empty. This is a result called empty, and this is our operation. Okay, this will be the same, will be the example 9. Okay, then here our operation. Okay, this is another project called efficient prime number. Okay, and we also some IP address validation. Okay, you can see it. Okay, IP address validation. Okay, thank you all.